What's up? I'm Transtormers and welcome back to the lab. Ignore the constant mess. What's interesting about this just random two stack of Fluke 70 series meters? Well, this is a 77 series 3, and this is the classic 75 series 3 that got supposedly slapped with a 308 is the story that, was passed around at the Hamfest. Anyway, with this one here, we are going to see if it still works. The screen has been harvested from it as well as the fuses. I don't know if that was prior to, it getting shot here, but it did pass everything on the board, technically, is still intact. So we'll see. All 70 series meters, as long as they are the same generation, use the same LCD panel, so we're just going to take one from one of our working meters and see if we can get that 75-3 working. The range switch is unaffected and does still cycle just fine through the ranges, even with this rather catastrophic damage. We can see that it was in volts DC mode when the damage occurred. Let's get right into it, tear into them, and see what we can get done. And that should be our thumbnail, maybe. Anyway, we have quite a few of them, and so I don't really know exactly which one we're going to harvest a screen from, just temporarily testing. Screens for these meters are around $40, so I would rather, know if it works before we order one. I'll just make a quick decision here, and we'll open one of these up and transplant a screen. So, the two screws missing from this unit already. We do know that it did pass everything on the board just fine, so we didn't have any, catastrophic damage there. Let's just use this one. I should technically, I'm doing this one first, but I also have a repair video for an Amprobe DM78C, I think, pocket meter. So we'll go ahead and get into that there. So anyway, as you can see, that's how easy it is to swap these buttons if we want to with the other unit. Basically, they're all the same sort of. We do have a fuse in here, that's interesting, but we don't have a fuse there. But anyway, as you can see, the massive damage from whatever round went through that, supposedly, did not actually hit any of our components, so that's good. Mobs look undamaged, other things there, even the wire round resistor is fine. So, but it is missing the screen, so that's a thing. Anyways, let's dig into our good unit here. Anyway, here's this unit out, and we can do a repair. Chewed buttons. Not chewed buttons. Yay! Now we will give this unit a peace offering of replacing its damaged buttons in exchange for the temporary use of its screen. We'll see if it agrees. And in true Fluke fashion, there are screws under the fuses, as they do. So, let's get those out. We have this heavily arced screwdriver. Suppose that's okay. Not really, but there we go. As you can see. The fuse we'll just set aside for now. Yeah, there shouldn't be anything under the milliamp fuse, the 440 milliamp fuse. There should be under our 11 amp fuse. And that is a single screw here. There should be some spring tension, which is keeping... Let's see if that's magnetic. It is. Okay, cool. Let's see, now everything should just sort of lift out, and it does. And we can see that this board looks really nice. That it says here that this is a 77-3-3001 Rev A. So that's cool. I'm just going to set it back down here for now while we... This one's interesting. It has a Protec fuse. Normally I've seen Bussmann fuses in these. And it does look heavily arced there. Let's give this a beep and see if it's alive or not. I would normally use my, main 390A here. However, because we're working on Flukes, I guess we should use an 87, right? In the spirit of things. Anyway, let's see on our, good meter. Yeah, that fuse is fine. The fuse we took out is also fine. This really toasty looking Protec is also fine, so that's cool. I'll just put that in the carcass of that one, and we'll get to take... Oh, the screw is not even in here. Someone had this apart. Or they, well, yeah, they did, because they had to take the freaking screen out. Okay. So, that's a thing. I've never actually been this far in it, I don't think. Anyways, we should be able to get the screen off by undoing. We are missing some screws, actually. That is intriguing. Notice the board says 75.3.3001 Rev C. We compare the two, we can see that they are pretty much identical boards, and there's not too much that's different between them. So anyway, we'll take apart this one first. Okay, we only had 3 to take out in this one itself here, and this whole sort of cover comes out here. This screw you do not need to take out to take this cover off. Our rotary switch there looks pretty good. I'm not really seeing too much damage to anything, and like I said, what is rather interesting is how nothing was damaged on this board. Like if our resistor network there was precision resistors were damaged, that would be a total to try and have something in there. But fortunately we don't have to. There is a lot of darkness around this area, but it does appear to just sort of wipe off. Anyway, that's that one. Let's go ahead and get into this one here. Anyway, here's a 75 and here's a 77. As you can see, they are basically the same damn meter. Cool, alright? Why is that gold plated? Or at least it looks like it. Pretty strange. Our mauves look a lot more delicious in the 77 and very edible. Not so much in the 75 here. Okay, here we are with our 77.3 display assembly. We're not going to bother transplanting the LCD and the zebra strips. What we're going to do is just move this good unit over to the 75. Is just go ahead and take our good display assembly and place it on our bad board, possibly. We don't know yet. And this is not a permanent install here. This is just a test. We will be giving this display back to our, known good unit. What I am going to do here is give our fuse over to this guy. That way we can test things. And what we're going to do here on our parts unit, well, that has just been moving around in there. Let's put our piezo back there. And let's set this in here. Okay, ideally what you should do here is you should hook it up to a lab supply and limit your current real low and slowly turn it up until things happen. I'm not going to do that because, oh, look at that, it boots. It boots. Well, that's a spoiler because we left it in on voltage DC. The piezo is totally not working. It probably fell out already. Let's make sure that it didn't. Okay, it didn't. What actually makes contact with that? Because this goes here, piezo goes somewhere. How the fuck does that even do anything? I don't know. But anyways, spoilers, it works. So that's cool. Let's take these battle-scarred buttons because that'll look better in here anyway. And it's still, ignore that it says a 77, it is still a 75. Oh god. There we go. Let's see if we do. It's just going through the ranges here. Oh wow. Oh my. Okay. Well, that's not good. Negative ohms? I mean, that shouldn't be possible. Interesting. That's kind of worrying, I guess. Amperage DC. Well, but the damn thing lives, so that's cool. So it is worth getting a Well, I mean, let's see. Let's see how well it does, and then we'll decide. So that's working at the very least, but our piezo isn't. Though that was falling out in garbage, so I don't really expect it to. Ohms range is just all over the damn place, but it does 0. So that's intriguing. We'd have to see what's up with that. Millivolt range, average, pretty good. Voltage DC, you know, average. Voltage AC, let's go ahead and just stick it into an outlet here. Nothing. Okay, well that's on. So, we're in voltage AC. Let's switch this over to AC here. This is an averaging meter, so it should say 5.55 volts. And it ain't saying shit. Yikes. Let's go ahead and go back into DC voltage here. This should be 5 volts. And you're seeing nothing. Damn, it might not be worth it. Millivolt range. We don't even get an over range. Ohms. We're up in the thousands. We could essentially sort of 0, but then it keeps climbing. Let's test a few resistors here. This should be 100 ohm. Nope, measures as like nothing. This should be 1000. Nope, measures as like a short. This should be 10,000. 100,000. Nah, you got issues. Set up another one here to use our Fluke 87 to measure the output in diode mode. It measures 2.48 volts or so. 2.48 when that's in diode test / ohms. But yet, we don't see shit. Logically, it is working. It's driving the screen. That's cool. So let's see what we can find out. Actually be bad there. Yeah, and we have like a little plastic thing across the piezo there to hold it in, which we do not have on the 75 over here. Let's see just for a second here if we were to put this in the 75's thing here. So it should beep when it comes on. And it does. Okay. So there's just something wrong with the piezo in there. Still, if we were to go into ohms, we're seeing a low reading that just climbs up slowly, as if we have some sort of capacitance issue going on there. If we hit the unit, we can get it to drop by like 20 for a second. For a second we saw overload. That's what we want. I'm going to go ahead and take out the screw that holds in the cover for the resistor network here. Just see, you know, if that's cracked or anything. Oh, there's a bug. Yikes. Just chilling on our resistor network there. Come over and check our sort of input protection side. And also we will measure our known good. Sup, future Transtormers here, and I'm going to save us a bit of time and show you the schematics and the results of the measurements I'm taking here versus our known good 77.3. I'm focusing on caps, resistors, the precision resistor networks, and mainly our input protection. All of our precision resistor networks and caps checked out, matching our good Fluke 77.3, as well as being within the spec of each part.
RT1, the main PTC thermistor, measured 1240 ohm, which is still within its spec as it's rated to be 1100 ohm plus or minus 20%. R1, measured completely open, infinite resistance, so definitely blown, should measure 3.5 kilo ohm per service manual. RV1, the first MOV/varistor in series, measured 87.5 kilo ohm, which is very low as a fully working/good MOV should not have a discernible resistance measurable by a normal multimeter. It should just show as infinite. RV2 measured 119.4 kilo ohm, which is slightly higher but still way too low. RV3 measured around 90 kilo ohm in circuit, but infinite out of circuit. Even though some parts may still measure in spec, like the PTC and our third MOV/varistor, it's good practice to replace them all after any high energy event that blows R1 or damages any of the MOVs.
Yeah, upon closer inspection, that does appear to have its blown out of it. But they did clean up afterwards. Okay. We can bodge in something to see if that'll fix our issue there. So it looks like there was a high input surge that happened. Since this one is literally a dead short, what I'm going to do is tack that resistor on there. Okay, now we've got a 3.3K just across there. Let's see if this does anything, I suppose. Okay, this should be 5 volts DC. Hey, look, we got life! We repaired! Good God, we need a calibration, but, you know, it's alive! We should get an overrange like this. Yep. Let's go ahead and switch this to AC. Yeah, 5.39, that should be about 5.55. Okay, so we're able to measure AC and DC now. Okay, I'm back, and here we have the actual replacement fuses, 630 milliamp. They were actually made by Bussmann. But, you know, Fluke. Okay, let's let that boot up here. There we go. So we still have an ohms issue, but it has settled here and is not progressing further. It's just settled at 207, so we can fix that. It's probably the MOVs there, the resistance that we were reading added up. It is. So we need to replace those MOVs. Interesting math here, when we did measure these on that MOV is like 89, or that's like 82K, 89K, and then 120. If we were to go here to our ohms range, we're no longer floating, we're just at a solid 210. The way those are structured here across that rail, 89 plus 120 equals 210. So I think that's where our phantom sort of resistance is going. If we, you know, short it out, we can here. So this should be 100 ohm. That's out of spec, but roughly there. This should be 1K, and that's also out of spec, but roughly there. This should be 10K. That's drastically out of spec, but there. We're going to get more drastic as we go up. Like that. Drastically out of, that should be 100K. So that is working like that at least. If we were to go to AC voltage, we're measuring 114.5. That's off by quite some. We now have a meter that is working, but drastically out of cal, and we can assume that some of that reason is due to our hilariously not to specification resistor that we put in just to bodge it into being functional here. Most likely are having that ohms range issue here due to these MOVs having a low internal resistance there. To our DC amp category, ignore that doesn't say DC there. It's not screwed in place. So on DC, this should measure 1 milliamp. And it does. Look at that. Bang on. Let's go ahead and switch over to AC current. Should measure, yeah, 1.11. Which matches our other in-cal Fluke. We did not test the amperage range, which we will do now. Turn that on to sync here, and turn our current limit up. Looks like we're tracking here. Let's go to exactly, roughly 100 milliamp, and that is bang on. Don't know if you could see that there, but that is accurate. And let's just go to, like, say half an amp here. We just don't have the resolution, but that is bang on accurate, so that looks good. Let's have this sync up to, say, a whole amp here. And that's within spec. Yeah, there we go, within spec at an amp. So, welcome back to the lab. This is part 2. Now, a few things. Shot meter here, Paperweight, is disassembled again because we have some updates. We have a donor screen here that we ripped out of the wide Putin edition, which will look nice in this unit, so we'll throw that in later. Also, we do have some replacement parts, as you can see here, for our input protection that came from Mauser, not a sponsor. Really would like them to be, though. Ooh, all right. Anyways, what we have is a new PTC here, which is the correct one, and that is these. That is our correct PTC. Ooh, look at the candy. Snacks. Anyway, these are supposedly the modern equivalent of the mysterious mobs there, the 1399 from Little Fuse. These are the closest equivalent to the K575, which they're using now. These are the V575LA10P varistors, and they're right there. Problem, as you can see, they're a lot bigger. And just like the service manual says, we've got some Dale 3.5K 1% instead of 5%, 20 parts per million, 5-watt wire wound resistors here. As you can see, that's that. As you can see, that's that. So they're very much different. And that's a slight problem for clearance and fitting things. And no, the 5% version is still this big. So it is not an issue with that. Even if I ordered the less accuracy, that is tremendously a different size. The thickness I don't think would matter too much. Our spacing here is definitely off, and we're going to have to do something about that. That's yikes, right? So anyway, what we're going to do for now is just tack this on and make sure this works. There is no way that this little guy here, which dimensions are not that, I'll put them on the screen here for our dimensions. That is definitely not a 5-watt wire wound resistor, because that's what this would look like. And the dimensions for that I'll also put on the screen for that part number. What we need to do right now is we need to undo our bodge here, roughly get this installed here, get the screen on, that way we can kind of see what things are behaving like. So for instance, I'm just going to try and tie that on to the sides here, and then we'll just close it over it and squeeze it and hope it works. So that's the part numbers of this one that came out of a donor 77.3, and we already have the zebra strips applied. Anyway, what we're going to do here is get this into this. We know our orientation because of the way that was, which is quite helpful actually. So what we're going to do is focus on separating this. We can do that by just prying at the side here and sort of taking that off. That was way easier than anticipated. Anyway, what we do then is we place the screen inside here, and we make sure that we line up the zebra strips through their mounts here. Just like that. So that the screen is in. There we go. Then we'll clip on our faceplate again. I'm just going to go from the bottom and push it over the top here. Oh yeah, that's why we didn't see that, because it's covered sort of by the bezel there. So now this is in, and all we're going to do is just sandwich that to that, power it back up, and see here. 3.499, 3.498. It is a 1% 5-watt wire wound resistor. These mobs, like I said, are going to be a complete pain getting in. I did do some math, and there is some other ones that might be suitable here. I believe the V480 LA7P, the 7mm ones, because our spacing, hole spacing there, leg spacing, is about 7mm. These are supposed to be 10, but are about 11.5. So what's rather interesting here is that these, in general, are bigger than what the datasheet says. So even the 7mm ones are going to be a little bit hard to get in here. Okay, so we're bypassing that blown one there, and we still have our mobs, which are a problem here. What we could do is take off one of each of the legs, and then that'll clear. You don't necessarily, in the absolute apocalypse situation, you can get rid of the mobs entirely, and the meter should still function fine. You won't have basically any of your input protection, so don't do that. Do replace them with literally anything else you can that would fit. Would still be better than completely removing them. Well, there is no service manual that I could find for a 75.3. We can find the service manual for the 77.3, and that lists, as well as like an 87.3 and just all of them, list that the resistor R1, which is what that is, should be 3.5K, 5 watt, which is way too big for that area, wire wound, and 5% with a 20 parts per million temperature coefficient. Now, this ain't that. And also, interesting findings, I'll link some pictures or just show you what other ones look like there. What's really interesting is the other units, 2 of them, have completely different, not a wire wound resistor, a metal film normal resistor with color codes, and it's a silver color code, so a 10% resistor, and they're 1K. A 1K 10% resistor, about the same exact size as our original one there, which doesn't look like a 5 watt one to me, maybe possibly a 2 or a 3 watt. So that's really weird. Let's see if we can temporarily get life out of it here. Whoa, put the battery in from the behind. Or at least we don't. We should probably ask the meter for consent. So let's turn the unit on. Yay, it boots up, but we are missing parts of our screen. If I squeeze them down, it's kind of okay. So we'll just squeeze that down. Let's use some original Fluke leads over here. I'm just going to steal aces again, because why not? There we go. And we are in the DC mode. Before it was quite wildly off, and now it is still just as quite wildly off. 4.86, 4.87. Should be 5. Let's switch over to AC here. Should be 5.55. 5.38. Basically the same as it was. A correct service manual correct one is not going to have fixed our ohms range. Now see, we still start out at like 200K or something. Let's see if we're able to calibrate it for this. So I really don't feel like we need to get a 1K. If the service manual said a 3.5K wire wound 5 watt, just to get a different wattage apparently, because that is not a 5 watt one that's in there, and is most certainly not what's in these either. Well, since we're this far into the damn thing, I'm wondering, should we just try and half-ass this? Let's try and half-ass this, why not? Let's take the screen back off, because that's what we have to do all the time. What we want to do is get these mobs out. Now, let's invite our friend, a new Japanese friend, to suck them off real fast. If you don't have one already, just freaking do it. They're so nice. This one is an imported one here, so I'm going to hook it up to a Variac to be all proper. Realistically, North America's close enough. They probably don't have to. Might just need to recal the temperature adjustment, but we'll be all proper because we do have the gear. So let's go ahead and do that. We got our Variac over here at 100 volts, which is what this wants, because it's a Japanese model. And essentially we've got our temperature all the way at the sort of bottom here. We can turn on our vacuum, or if we turn the unit on, of course. Well, there we go, now it's on. Barp, barp. Finally got one of these. So what we're going to do here is just solder off the mobs, which are these two, those two, those two, and then we'll try half-assing some of those in with some pliers and just magic, because, you know, why not? There we go. And our V3 is out. And all of our traces there are nice looking. You can see right through them. And on the back side, look at that. Nice. Nicely done. So, let's see if we can kind of half some of these in. I'm going to go ahead and turn off the Hacko here because it doesn't need to do anything else for us. Let's turn our temperature back down here. And yeah, that's pretty much it. Let's re-tin the tip as you should with everything before you put it away. Nice. Okay. Don't have to reseal the tip, in other words, but just re-tin it. For now, this is really hot and such, so I'm just going to set it in my designated spot over here. And by that, you know I'm just completely lying and just propping it up against something. Okay. So, now that those are out, we have our surfaces ready for our new ones. How the f*** is this going to work? Well, that's a good question, because it's not. Let's see if we can half some other things in the meantime. We're going to need some tiny little baby needle nose pliers. Okay. So, we need to adjust this to be about a 7 mil hole spacing. That's going to be brutal. So let's see if we can do that. I'm just trying to do something like that on each one here. Let's see. Well, hot damn, I'm amazing. No, right? Just by eye, you know, like just a professional. Anyways, I don't know. They're really big. I don't know if that's really gonna like work, but we can certainly try. Let's replicate that on all of our other ones and see what we can do to get those in. We don't want to add too much height to the thing. They're already so damn tall, and that's one of the issues here. I don't know, Chief. I don't know about that. I don't know. We should change the PTC with the brand new PTC, because damn it, it's a brand new PTC, and this one survived whatever happened here. Because it is functioning fine, and it reads roughly okay, but it really should be changed. It's a fairly cheap part. So let's put in a new one. And besides, this non-encapsulated one is what like the newer meters use, or at least it looks like on a few of mine, so we'll use that. Okay, now that that one's out, let's get our new one in. And this is also going to mess up our calibration by quite a bit, because that's how this works. Beautiful joints, in my opinion. Slash everyone's. I mean, look at those. That's what you can achieve when you use evil leaded solder. Alright. Let's see here. Holy freaking crap, if that actually works, I do not think it's going to clear. But if that works, that would be really, really cool. Let's test fit things. The mauves, anyway. Let's test fit the mauves with this. Look at them nice red candies in there. Okay, so it is probably possible. Oh, that would be so cool. Let's make sure the range switch would be able to cycle here and not get caught. Look at that. Oh, and look at how nice that looks. Okay, now the only chore left is to see if we can get this guy in there somehow. Pro tip, let's do something stupid and leave this on top. Wow. Wow. We soldered them in. Those all look pretty dang fabulous. Turn this back down, turn you back on, suck out that one. Back to like 2. Oh, so it's so damn tempting to use it, isn't it? Let's try that. Pretty certain I've got those the right way around. Oh well. No matter. There is no right way around for them. I just mean the right, you know, each one going into the right pins there. But we should. Let's see if we boot here. And we boot. We boot. And our ohms range is cured. Look at that. OL. OL like it should be. Now, let's, while things are heating up and while everything is completely everywhere, and this is really stupid. Well, let's plug things. Oh, we can't set that down. Holy f***, we almost just shorted everything. Okay, well, let's do this one-handed. Paperweight. Paperweight to functional meter, question mark. Ohm, come on. 99.9! Holy sh**, look at that! Okay, now this one here. 1000, oh my god, is this going to be perfectly within cal without even doing anything? That would be amazing. 10K, oh my gosh, is every range going to be on the exact number like this? Oh my god. Well, that's just incredible. Oh, under this, yes, of course. Missiles. Missile. 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 There we go. Nice. We can wash off the flux later. Okay. So what we're going to do here, snip, snip. So we snip, snip. Now we're going to unsolder this one. This is going to be hell because that's huge. Okay, now we've got out our, oh my god. On the reverse side we can see what it was. So, for anyone playing along at home or just wants to know if Fluke is an asshole or not, it's a Dale, I'm trying to read that in the camera screen there, it's a Dale RS-2C 2K 5% Mexico M0031. Imagine that. Freaking imagine that. So it's not a 1K, because it wasn't within cal in either orientation. Yeah, that explains it. And then half-ass a way too big resistor that's the right wattage according to the service manual into the Fluke. All prepped and ready here for the new resistor. All you can do is hope. Moment of truth. Yo. No. Can we just leave it up like that? Can we just leave it totally just in there? Would that be a thing that we can do? Let's see. The answer is no. No, we can't, because we've got a lot of that section there covering it. Get these darn metal shavings off here now. Let's see if we can get this guy in here. Wonky wonk wonk. Now we're too much in the other direction, because that's always what happens. Ah, look at this abomination with me. Look at it. Look at how pretty it is. Well, let's see if this closes, and then we'll solder that up, and then we'll just, yeah. Yeah, you know, it's some of this. It is some of that. Pushed inward. See what I mean? Too much of this from the bullet hole is going inside. It's bent in. And that should ideally be flat. See what I mean? Not bent in like that. So I'm going to try and bend it back. And if that doesn't work, it'll crack. That piece cracked. Alright, that looks fine. How's that look? Should we just solder it in just like this, I guess? Yeah, let's just solder it in just like that. Let's see if we can missile. Missile! Literally, this one's gonna shoot so far behind me, watch. Literally onto the, like, other side of the room. Okay. So, here's our board. Before and after. Okay, we can still see all of our digits there, so that's cool. How cool is that? Successful repair. Let's put in our chewed up buttons. See the slight chewing on that one because it looks awesome. $5 volts DC. I just switch to it. 5.53. Let's switch our frequency back to 100 hertz. 5.53, 5.54, so within 2 counts, still within spec there. Need to find a screw to screw the board down. Let's see, so 100 ohm, 1000 ohm, 1000 ohm, 10K, 100K. Don't want to use hot glue, but what we had originally was a strip around it. Let's see if we can fashion something like that real quick here. While that's heating up, let's see if we can find a screw that's similar enough for either this or that or whatnot. Let's see if anything here is usable. Nope. Back here. Can you by chance be used here? Yay. Well, that works. We'll use that one, or we'll try to use that one. But first, let's do our stupid Mylar trick. So the piezo is supposed to, those two, or more so, these two dots here on the board, those right there, are what the conductive rubber, Fluke's original conductive rubber connector usually touched. And they are just little solder blobs, just rounded little solder blobs is all that those are. Right there. And that's where we're going to have to pull the signal from. So for instance, the way they had the piezo in here looks very much like this. I just redid it with a little, basically, strap made out of trash there. This is what it normally looks like here. Just a normal strap that's then plastic welded in on the sides, just like that. And then we have a very tiny little conductive rubber sort of dots there
which is hard to see when the camera's this close. Here, this little dot here, and then that little dot right there. And those are actually conductive. That's what touches the board itself and triggers it to make noise. So that's where they need to be, unfortunately, if we were doing direct connect with the board, or if we were, I mean, we could try and, we don't want to directly touch the piezo to hold it in place mechanically. We could try and strap it across a different way and then use little springs, possibly. That could be a way we can do that, or what we can do. That's assuming this one works, by the way. We don't really fully know that, so we're going to try that right now. Yep, that boots up here. So, I'm going to just try and hold this on to here. Let's verify that. So the top one, top right hand side's inner. The bottom one is going to be the outer track. Yep, that piezo is fully functioning. That's cool. Basically what I'm doing is just adding them vertically like that. Now the problem that we have to solve over here is undoing this, bridging it across a different direction, that way these can touch there and there. So what we've done is we've taken some mod wire, or, well, solid core foam line, we've tacked that here and made them vertically go up like that. They are tinned, and essentially we've restrapped this ways instead of that ways, because we need to make contact with the points there and there. We know that our piezo does work, so what we're going to do is trim off some more of this. Hope this stands up high enough. Hopefully. I'm going to say that's an okay height there. Just like that. Whatever that is. So essentially what we're going to do is put this new screw, or replacement screw, back in that clamps the board down so the piezo can even do anything. There we go, it's nice and tight. A fuse back in. That way everything's correct here. And realistically, let's steal some screws from a different one. There was one here that was very dirty. Or I mean, the screws were really garbage looking. Let's steal the screws from that one. Here. It came with a case, but look at how disgusting its screws are. I mean, we could probably clean those up, but they look pretty damn oof. So we'll steal these, put them in here, steal those, put them in here, and then get some new ones for that or something, just to finish up this repair in its entirety here. Let's put in these nice pretty screws from a wide Putin edition. Okay, there we are. Now on our nice meter here, we've got the 4 nice screws installed. Now we have a nice set of 4 screws here. Well, they're not nice, they look like but yeah, like look at these. Yeah, see, heavily corroded looking screws. I do have some steel wool here. I don't really want to take off their paint completely, but let's see if we can get these to look any better here. Okay, welcome back. We've cleaned the heads of these screws up with some steel wool here. A lot of the original blued coating is missing. However, at least they don't have a lot of corrosion on them anymore. And I think the distressed look will look really good in our, you know, freaking shot brought back necroed meter here. So this will be quite nice. There we go. And that's our full repair of the shot Fluke 75-3. Let's make sure we still have beeps, and we do. Let's go ahead and put our generic test leads back in. Try shorting them together here. Yay! Fully repaired. Before we fully finish this video, we'll go bring it over to our Fluke 5100A calibrator, and we'll just give that a C there. 1 second, I don't know where in ohms range. Let's give our DC voltage scale.
Yeah, there we go. Yay! Fully repaired in its entirety. This was one of the most fun repairs, to be honest. I didn't think I'd ever really get this one fully working again. Bought it as a, or not bought it, came, I think they wanted $5 for it originally or something like that, and then just bundled it in for free with other stuff I was buying. I really did not expect it to sort of live again, but we got all modern input protection equivalents in there. Still from Little Fuse, as you can see. Listen to the glorious boot beep. Listen to it. Hell yes. Yeah, that's that. Cool.
Thank you for watching, and make sure to stick around if you like this.